Okay, maybe this helps you just for a second. This is scientific notation. 1 times 10 to the third, that's the same thing as 1,000, right? 4 times 10 to the third is 4,000. 1.6 times 10 to the fourth is what number? You move it over 4 times. 1, 2, 3, 4. Fill the rest in with zeros, right? 16K, and that one's 64K right there. Right? Yeah, they are. All right, now, so if this is true, this pattern, you can see the pattern is just multiplying by 4, right? Multiplying by 4 is not the same as adding 4. So on this question here, you have 4 different options for your function. This first one is linear, right? Yeah. Linear functions go up the same over each certain time period. This one here would represent up 4,000 every 1 year, right? Up 4,000 every 1 year. That's what letter A would say. It also means that it started, oh, my drawing's not going to be real good. Started right there at 0 because the y-intercept is nothing. Okay, letter B is really similar to that. Letter B is also linear. Yeah, it just means it starts at 1,000 and it adds 3,000 each year. It adds 3,000 in the first step, but does it continue to add 3,000? Obviously not. Therefore, it has to be exponential. Exponential functions grow like this on a graph, right? At first, it might appear to be flat and doesn't grow near as much as a line. But eventually, if we had 2 functions, the exponential function generally will overtake a linear function. It'll overtake it, right? It'll pass it. So in this case here, this is exponential. It can't be A or B because those are linear. So which one is it? Is it 4 to the negative t or 4 to the t? 4 to the t. 4 to the t. If it's a negative exponent, that would mean it's actually decreasing. It'd be decay at a certain amount. All right. So let's use this question as kind of a format. Here's what you should write. This 1,000, draw a little arrow underneath and say starting amount. This is your start. We've done this before in here. Sorry about my handwriting. Okay, what's the 4 represent? Well, the 4 represents your growth factor. You could also call it the common ratio, is what some people call it. So what happens from one step to the next? Sorry, I can't share screen from this laptop. I'll try to get it figured out. All right, so on a lot of these questions today, there will be 4 choices. 2 of them will be linear. 2 will be exponential. You should be able to figure out from the context of the problem given to you which 2 you can eliminate. From there, we'll have to use our knowledge of each kind of function as a step forward from that point in time. Okay? Any questions on this one? Okay, let's try out these 2. Let's pause, take a little break. Let's try these 2 right here, 2 and 3. Here's the key. Number 2, simple interest. Number 3, compounded. Semi-annually, that's compound interest. That's why you have each of those 2 formulas written down today. All right, so try those out real quick. So the first one, it says simple interest. Simple interest. Simple interest is linear. Oh, that was a terrible line. But simple interest is linear.
To anything, it's not right.
I still can't draw a good line here. Let's try it one more time. Okay, there we go. There is no exponent in the formula. Look at it, right? Mathematically, we should start to see these things. Look down at compound interest. What do you notice up there at the top?
There's an exponent.
There's an exponent. This one's exponential. Compound interest is the 8th wonder of the world, says Albert Einstein.
No, he did not.
It's because of that reason, right? It grows so quickly, right? Now, Simple interest is up here. It is not exponential. It is not exponential. It's not C or D. That's what I mean. You should be able to narrow these down. Give yourself 50-50 shot. Last thing is, if we just use the formula, we start with 1,000. P is your principal. That's what your starting amount is. Then it says 1 plus the rate times a certain amount of time, which is, in this case, they call it K years instead of T. There it is. It's B. A looks a lot like it, and you might even say, well, aren't they the same? Well, not quite. In order for them to be the same, there'd have to be a 1K right here. If there was a 1K, then you could combine the like terms. They look really close to the same, though, right? Anyway, it's still B. Number 3, it's compounded semi-annually. Think of this way. What's that word mean? Well, semicircle is a half of a circle, right? Okay. If something compounds monthly, it would compound 12 times in a year. So if something compounds semi-annually, it compounds every half of a year. So how many times in a year does it compound? Two times. So what that represents is right here, the letter N. N is the number of times in the year in which it's compounded. So it's got to be D. The reason is the rate is still 4%. So in the parentheses here is this step where it says R over N. R over N is 0.04 divided by 2. And that's where the extra 0.2 comes from. 0.02, excuse me. All right, real quick, go to the next page. We're going to skip 4. Go on down to, there's actually a question. Take a look up here. It says example 8. It's right underneath question 4. It's like hidden in there, okay? Let's try example 8 real quick. Let's work on it together real quick. Which of the following types of functions best models the number of books in his library? Well, every month Jamal adds 2 new books. Adds. Exponential functions would require multiplication, right? And that would if he did that, that'd be an enormous library. That'd be hard to keep up, right? So Jamal adds 2 new books. So it's increasing, obviously, can't be decreasing. And then it's linear because you're adding the same thing each time. All right, this brings me to one of the con assignments we're going to do today. So one of the con assignments is this one. Take a look at this table. This function right here, is it linear, exponential, or neither? Here we go. The first thing I would do is compare them, figure out how do I go from there to there. So in this case, it's adding 3. If I add or subtract the same amount each time, it is linear. Very good. This one's adding 8. This one's adding 20. So it's clearly not linear. Next, it could be exponential. Exponential would require that it's multiplying by the same number each time. However, I can see from there to there, it's times 2. Is this times 2? No. One way you can always work backwards to figure out what they're multiplying by. So like let's say you're not real good at fractions. You're trying to figure out, how do I go from 9 to 12? Well, work backwards. 12 divided by 9. 1.3 repeating, right? In order for it to continue, I'd have to take 12 times 1.3 repeating. The next number would have had to have been 16, right? If you round that up. But it's not 16. So it's not exponential either. In this case, it's neither. All right, that's one of your assignments we're going to do today eventually. Also, this is a model. So a model is a relation to the real world. Here you go. The number of tadpoles in the pond triples each day. Which graph best represents the relationship between time and the number of tadpoles? If something triples, it's being multiplied then, right?
So it's exponential.
It's exponential. Exponential is not a straight line. Exponential is a curve. All right, let's do another one. Is this linear or exponential? Let me get this up here. In this case, we added 7, and then we added how much?
10.
And then we added
15.
And then we added
21.
21. Did we add the same amount each time?
No.
It could be that it's neither, but in this case, they don't really give us a choice, right? Since they're not adding the same thing, it can't be linear. One way you could do is prove it like this. 23 divided by 16 is that number. I'm working backwards. And then 33 divided by 23, it's almost the same number, right? This is an estimate because the question even states it in that kind of loose way. It says, what kind of function best models? It doesn't have to be exact. It's close to exponential, right? If we picked another 2, 99 divided by 69, that's 1.43 again, right? Okay. For now, here, we're going to do a worksheet.
Pass them out.
Yeah, pass them out. They're up here somewhere. It looks like this.
Linear and exponential growth.
Yep, that one there. There you go. Okay, we're going to do these 8 questions in class. It's not for a grade. I'm not going to grade them, but you should do them. And then we're going to go through the answers at the end. These are questions like you will eventually see on a quiz. Okay? So take some time here. We're going to take about 8 minutes. Deal? 8 questions, 8 minutes. All right, here's the answers. Let's kind of go through them real quick. Number 1. What'd you say? Number 1 is A. Yeah, it starts at 0.5 and it doubles. That means it's exponential.
Amen.
Starts at 0.5 and it doubles, right? Number 2, it is exponential. So you should be able to rule out letter A and letter B. There's no exponents. And then because it's exponential, the variable should be an exponent, right? It starts at 5. Well, it doesn't say that, right? Anyway, it says it doubles in area, so it's got to be D, right? That's your rate. Number 3 is a little funky.
It was a little
So the algae and the minnows both grow at the same rate, except the algae starts ahead of the minnow. So can't be D. It's exponential. They're doubling, right? That's a linear graph. Letter B is incorrect because that would imply the minnow is growing faster. So it's got to be either A or C. Here's how you can think through this. If you double $1 million, you just made $1 million, right? You increased $1 million. If you doubled $10,000, you just made $10,000, right?
Yeah.
One graph will appear to be going up faster than the other, though.
Yeah.
It's got to be A. See? C has the same kind of slope to it the whole time. It's not the way exponential functions work. What's actually happening is A is correct because the algae and the minnow are just like off horizontally. If you shifted over the minnow a little bit more, then it would match up, right? Anyway, number 4 is A. Number 5 is A. Eventually, the exponential will overtake it. Number 6 is half-life. Half-life means it's cut in half. So if I start with 8, I cut it in half, I get 4. If I cut that in half, I get 2. If I cut that in half, I get 1, and then a half. I'm not taking away the same amount each time. It has to be A or B. Then we start with 3, and it happens every 5 years. If you think back to our unit on exponential models, it has to be A. Here's the reason why. It would be cut in half. If you plugged in 5 for X, 5 divided by 5 would mean it got cut in half one time. That's why. All right, number 7, it's linear. So it's D. It's 8. Sorry, on number 8, it's the opposite of number 6 because it's doubling every half hour. So that means it happens 2 times every hour, which means the answer is B. That's why the 2x is up there on number 8. Keep that for future reference. Your con assignments are available now. If you have any other questions, holler at me. They are due tomorrow at 1:45 in the p.m.